In the previous video, we talked about the Aldol reaction. Now this is a very similar reaction and it involves the mechanism from the Aldol reaction, but we have slightly different reaction conditions that promote the reaction to proceed a few more steps. So for the Aldol condensation reaction, again, we start with an aldehyde or ketone. So I'll show an aldehyde here. We have acid or base, but we'll focus on base in our class. We have water, and then we also have heat. So this addition of heat produces a slightly different product because the reaction will continue further. Now remember, when you're adding heat to a reaction, you're giving the molecules more kinetic energy, they're moving around faster, and so the likelihood that they'll collide with each other and produce a new molecule is more likely. It's a higher likelihood. And so adding heat generally makes molecules more reactive, and that's what we'll see here. So we have slightly different reaction conditions. And the final product is an enol, where we have an aldehyde and a double bond between the alpha and beta carbon. So this is an enol, en because we have a double bond, al because we have an aldehyde, and we can say this is an alpha beta unsaturated. Now we can also use ketones for this reaction, doesn't have to be an aldehyde. But just like the Aldol reaction, the name comes from using an aldehyde. Okay, so this is the reaction condition. Let's do the mechanism. And the first couple of steps is the Aldol reaction from the previous video. So we won't show those steps here, but let's write a note to see mechanism in previous video. This is how we start with the aldehyde. We have sodium hydroxide and water, and we form the aldol. So in the previous video, I could just scroll up real quick. We show the mechanism to start with an aldehyde and form the aldol. We first form an enolate, and then right here, nucleophilic addition, we're showing the enolate ion adding to the carbonyl of another aldehyde, and then we do a proton transfer to get the aldol product. So that's what we're representing by this first set of arrows here. See the mechanism in previous video for that. Now, if we have heat and we have base, we have water, again, this reaction will continue in a couple of more steps. When you form the aldol product, you still have an alpha carbon here that has hydrogens. So there are two hydrogens here. Now these hydrogens are still slightly basic for the same reason as alpha hydrogens are basic in standard aldehydes and ketones. So we have base present, we still have our basic solution, and we have these slightly acidic hydrogens. And so with heat present, the reaction continues. And we remove one of these slightly acidic hydrogens, and we're forming another negative charge on a carbon. So this step here is a proton transfer. This forms, we have the same bone structure, except for one hydrogen is gone now. we have a negative charge on this carbon, and we only have one hydrogen here. One was removed by the base. Now we know carbons with a negative charge are not very stable, and so this negative charge will form a pi bond between the carbon that owns the electrons and the carbon that's bonded to the OH group. Now when we're in basic conditions, we already have OH present in solution. If we were to lose the OH group, that will leave as OH minus, which is already present. We've got the basic conditions. So that's what happens in this step. We have this negatively charged carbon. We'll create a pi bond over there, and we lose the OH group. And so this gives us our last product, or our final product, where we now have a pi bond between the two carbons, and we've lost OH minus. So this step is elimination of OH minus. And we've formed the Enol product. Now you might remember that if we're forming a pi bond, in this case we could also form the cis version of the pi bond. So that would be this product here. So we have Z alkene as opposed to an E alkene. This is also possible, but it's produced in small amounts, so this would be a minor product. And that's because alkenes are more thermodynamically stable than the cis alkenes. So the trans double bond forms in a higher concentration than the cis. Now, this is called a condensation reaction. Condensation reactions produce water. So one of the byproducts is water. And that's formed in this step where we do this first proton transfer. So in this step, we've also formed water here. And that's our condensation reaction. So remember, if we have heat present, our molecules are a little bit more reactive, and the reaction after forming the aldol will continue and form the Enol product.